So this lesson is standard ARCH.8.EE.A.1.8.1a. The learning target, as you can see, is I can use properties of exponents to simplify variable expressions. So first of all, let's define exponents. Exponents are small numbers to the upper right of the base number. So example, here's a base number, the way you see it written on a sheet of paper. And the small number to the upper right is called the exponent. Okay, let me go a little deeper into this. What this means is you're going to multiply the base out this many times as the exponent tells you. So it gives you a guideline to do that. So what is 2 times 2, which is 4, times 2 equals 8? And that is what that represents. Now, usually, if you see a base with an exponent of 1, you normally just see the number 2. The exponent 1 is invisible, but you have to assume that it's there. If you don't see an exponent, the exponent is 1. Another example, if you see a variable raised to an exponent, it still means that's x to the power of 1. Here are some more examples of exponents, 4 types that you will see. So for example, we solved 2 raised to the power of 3, or 2 to the third, is 2 multiplied out 3 times. It's not 2 times 3. Do not multiply the base times the exponent. That would be wrong. Another example is when you see 1 divided by, or a number divided by, and you have a base and exponent in the denominator. You're going to rewrite what you see in the numerator, and you're still going to write out, as the guide tells you, 2 times 2 times 2. So your solution is 1/8. In this example, you have a negative exponent. Actually, you can help yourself out by making this positive by moving the whole thing from the denominator to the numerator, and you remove the negative sign. So 1 over 2 to the negative third is just 2 to the third, which again is 8. And finally, if you see a negative exponent at the beginning attached to the base, it basically means you want to get rid of the negative sign, and by doing that, now this whole thing goes into the denominator. So now you're going to put 1 over 2 to the third. The negative is gone, but you still have 1 over 2 times 2 times 2, which is 8. The solution is 1/8. It's a little daunting to look at the exponent rules, but it is a guideline, sort of like learning how to play a game. There are rules. So I can give you these, and you can make your own notes and poster to help you remember. Let's start with the first one. When you see one base and it's self-contained in parentheses, the base being A, raised to a power and then raised to another power outside the parentheses, the m and the n have to be multiplied. So for example, 2 to the third to the fourth is equal to, it's an equal sign, 2 to the third times 2 to the third times 2 to the third times 2 to the third. So really you have to multiply 2 to the third out 4 times. Now if you have 3, 6, 9, 12 of those, your answer is 2 to the 12th. And a shortcut is you can multiply 3 times 4 and get to 2 to the 12th much more quickly. The second rule is called the product rule. It's when you have 2 of the same base being multiplied, you're going to add the exponents. So a to the m times a to the n equals a to the m plus n. So if you had 2 to the third times 2 to the fourth, you're really just adding those, because 2 to the third would be 2 times 2 times 2, and then 2 to the fourth, 2 times 2 times 2 times 2. All of those being multiplied means that you have 2 as a base multiplied out 7 times. The third one is when you have different bases raised to a power, then you can separate them out and put the power above each variable. Number 4 is when you have different bases being divided, raised to a power. Once again, you can distribute the m to the variable individually. Number 5 is when you have the same base being divided, then you can subtract the exponents. Number 6 is when you have a negative exponent. It is the same thing as 1 over n. It's not a negative number. Number 7 is the 0 power. Any number raised to a 0 power is equal to the number 1. So example, 3 to the 0 equals 1. 50 to the 0 equals 1. Any number raised to a 0 power has a value of 1. The distributive property tells you to multiply each term inside the parentheses and make sure to also distribute the sign, whether it's positive or negative. So this first one is an example showing you a positive 2x being multiplied by this quantity. So you have to multiply 2x by 8 to get 16x, and then 2x times negative y to get a negative 2xy. In this example, we have a negative sign out front. A negative 2x being multiplied by the quantity 8 minus y means you're going to distribute the negative 2x times 8, which gives you negative 16x. And you're going to add, because a negative times a negative is a positive. So 2x times y is 2xy. And that completes this lesson.